Hello world! Welcome programmers! Welcome music lovers! Welcome to Code and Coda! We are streaming live from Boston, Massachusetts this evening. Today is Sunday, the 21st. Happy Father's Day to all the fathers out there. I myself am a father of 2 cats, so happy Father's Day to me. It's also the solstice weekend, longest day of the year, the summer solstice. And it's also MetroShare Solutions' birthday today. 7 years ago, MetroShare Solutions was started. How time flies. My name is Joseph Parzell. I'm your host tonight. I am a software developer and an app publisher. And my friend on guitar this evening is Eric Gaudette. I always get such great feedback about Eric's guitar playing. It really is great. Why don't we take another quick look at Eric? Well, here is our Season 1 abstract. We are currently in Episode 4 of Season 1 of Code and Coda. If you have been with us for one of the first few episodes, you may notice that this abstract has changed just a little bit. Remember, we are an agile team here at Code and Coda, and what we tried to do this week is sort of plan out the schedule for the rest of Season 1, and we decided that we would be probably going long for the response episode and also for the graph episode. So what I've done is similar to the request episode. I've just gone ahead and added some padding there for us, and you can see that we are planning our Code and Coda Season 1 finale on the 19th of July. So after today, we'll be halfway through Season 1. Why don't we take a look at the technical specification for episode number 4, Response. If you have a really good memory, you may remember that our old abstract used to say respond, but I've changed that name as well. No big deal, just kind of trying to get more consistent on some of this terminology here. We will, of course, go through a 5-minute recap, quick recap of last week's episode, episode 3, which was the second half of the request episode. Today we're going to update our dev environment a little bit more. So if you remember, we are using our get page of our web application to send a post request to our web application. So we'll be updating that environment a little bit. Today we will also be getting into creating an asynchronous function in C#. Later on, we will also create a custom response object, and we will use this object to send data back to your Alexa device and to the user. Don't forget, YouTube chat is open. Now, we will not be getting through all of these items today. We'll probably get through most of them, about half. Again, this will be a 2-part episode, so we won't be going through all of this today, but we'll try and get through most of it. So, quick introduction, why Code and Coda? This was supposed to be a Teams Thursday New England presentation. Back in April, the event was canceled, and so I took my idea and virtualized my slides. And since personally I thought maybe just presenting the slides online would be a little bit boring, I asked my friend Eric if he would provide some nice music in the background. And so Code and Coda was born, and as my good friend Jim Wilcox put it on LinkedIn, cool kids catch it live for the awesome code tips, cooler kids join for the music, and the coolest kids dig it for both. And I really do hope you are digging it for both reasons. So recap, episode 3, remember we completed our process of sending a post request to our web application. We're using JavaScript here and some Ajax. And so we can basically, with this method, we do not need to have an Alexa device or an Alexa emulator. We can sort of bypass having to do that. And so we sort of worked on that environment a little bit, and in our C# code, we utilized some new library, specifically System.Text, to parse our JSON data and decipher between a launch request and an intent request. And we published those changes to Azure, of course, and tested them out. And so for now, let's go as fast as we can through last week's slides. Before we do that, why don't we see how our special guest Alexa is doing tonight? And I meant to put one extra slide in here and I forgot, so my apologies. Hopefully it'll be in here next week, but I do recommend that you mute the microphone on any Alexa device that you might have within earshot. Andreas, sorry if something gets put onto your shopping list by accident. Alexa, how's it going tonight?
You caught me in the middle of doing the hokey pokey, so I'm all turned around.
She's in a joking mood tonight, it seems. Well, Alexa, please set timer 5 minutes.
5 minutes, starting now.
All right, here we go. So, like I was saying, we created a development environment so that we could debug our skill. We went through this diagram one more time, and remember we were going from 5 back to 4 and 5 for our development environment. And so we started in the UI layer by adding some JavaScript to our project, and then within this JavaScript we started creating a data object as well as some other functions like my custom Ajax function there. And last but not least, we have our post form function, which is what is called when we press the button on our get page. So this is the button that we press, and notice in our developer console on the right, we get the response returned. We remembered that we can now, since we are using this method, debug our web application. So back to the get page, pressing the button, we can see that we can set breakpoints. We determined that our object was null, so we started going through the process of adding some properties to our Alexa post request object, and then started parsing through that object. That allowed us to determine whether a launch
I didn't
request...
catch the other thing you said.
Whoops, forgot to mute Alexa. So, you can see here we are now just starting to see what data comes from our Alexa post request object, and so we started parsing through this data. We used the JSON document object from System.Text library, and then checked to make sure that we had some valid data by checking the value kind of the root element of those objects. If there's an error, you throw a JSON exception. And so remember, back in our post data object, we are setting the type with our launch button. And so when that comes through, what we want to do in C# we want to determine what that request type is, we remember that we should probably make sure that our variables are created outside of our code block here, and then we can access that data again later. Down in this second code block, what we did was check to make sure that the type again of this JSON object was correct and of type string. Lastly, we took the data that we got and passed that data to the UI layer using the view data object, and just quickly we took that view data object, created a variable called request type, and then placed that variable into the text response there, so that we can now click on our launch request and we see that we get the custom text returned to us. We went back to the testing console after publishing to Azure, and I'll leave it on that side. We saw that once we ran our launch request, which is Code and Coda, we get the response hello world launch request, and when we type in our intent request called help, we get the response hello world and intent request. So now our web application is smart enough to know the difference between a launch request and an intent request, and we can do all of that debugging without using the testing console or an Alexa device or emulator. I suspect my time is running out here. Alexa, how much time is left on the countdown timer?
You don't have a countdown timer.
Well, I guess I don't have a countdown timer. Not sure what happened there. We'll have to go back and look at the tape, I suppose. But hey, that's the less than 5 minutes for these slides. I hope that was less than 5 minutes. I guess I'm not sure. We'll get into part 1 of this episode next, but first, let's take a quick listen in at Eric. Sounds like I do have a countdown timer. Alexa, please stop timer. Well, hey, you know, sometimes software has a bug. It's a fact of life. We try to do our best in Code and Coda to make sure that we squash all of these bugs. Eric, you sound great. Cheers to the fellow coffee drinkers. Okay, so let's continue to debug our skill here. Now, today's episode response, we will start building the response. But I do have to admit, we will spend more time today looking at the request that is sent to the web application. So we're going to update our JavaScript a little bit today so you can see what that looks like. We're going to add some more data to our JSON data object. And we'll also update our get page so that we can pass this information a little bit easier. Alright, so here is our UI page, index.cshtml. And remember that we have a button here. When we click on that button, we are calling some JavaScript, and we are sending just a little bit of text here to our JavaScript function. Now, what are we updating in today's episode? This is the post data object that we created. And what we need to do is actually put some data into these fields. And specifically, we will be working with device ID, the API endpoint, and the application ID. So what I've done is just simply created 3 variables, set them to empty strings just to kind of get us started here. And then if you see, I replaced the empty strings within this object with those variables. And then where do I get this data from? The device ID, the application ID, and all of that. Well, I can go back to the Alexa testing console, and just first I should mention you can type in the launch request for your skill, and you'll see the request comes up on the left side, the response on the right. So within this request, we can sort of go in and yank out the application ID and a couple of other pieces of data here, and you can see that I just kind of pasted them in there. And try to remember this API endpoint. We will be using that in the next episode. But for today, we're just kind of going to get set up a little bit here. So now that our post data object is starting to take shape a little bit more, we can run our web application, and you'll see that when you click on the launch request button, I've added a breakpoint to the JavaScript, and now you can see we are changing the post data object here after we click that button, and we set the type of the request to launch request, or whatever value is passed in to this function. That's what that variable X is representing. And so what I'd like to see now is, what does our post request look like after we sort of made these updates? And so what I did was I just added another trace statement and a little prefix here. Before we didn't have these prefixes, the response here. So when I add my trace statements and I click the button, you can see this is our response. Now I didn't quite get what I was hoping for. You can see the request is showing that I'm getting an object, but I'm not able to see what's within that object. It's not nicely formatted like the response is. So I can quickly go back to my code, and remember, we want to stringify this JSON data before we place it on the screen. That will allow us to see what is within that object. And one more thing I've added here is a text area field, and what that is going to allow us to do is actually place dynamic information into this post data field. So when you see this text box on the screen, maybe you might understand a little bit better. What we have is a field called API Access Token. That field, that piece of data changes on a regular basis. I believe in this case it's every 15 minutes. So that's not really a static value that we can place within the post data object. Since this value changes frequently, we don't really want to hard code it in, so we give ourselves a text box to place that information into. And so what I've done is, you can see I've gone and taken the API access token from, from the testing console and placed it into the new text area that I've created. And to retrieve that value, we're going to use a little bit of jQuery. So back in our JavaScript file, we're going to try and update the post data object with our API access token. Now, where do we place that data? Well, if you take a look at the IntelliSense within the post data object, in the context object, you can see that the API access token belongs there. So with a little bit of jQuery, we can retrieve our API access token on the fly from that text box, from the text area element, and place that value into the post data object. This way we don't have to hard code that value in like we are with device ID and the API URL. That can be hard coded. That doesn't change. The access token changes, so with that method we can put that value in as we run the application. You can see here, this is the end of my access token, but after refreshing the page, and let's just take a look, the end of that is QXFA. After refreshing the page, after some time, now that access token is different. So you want to copy and paste that value into that text area field. When you click on the launch request button, then our JavaScript is now retrieving that access token from the text area and placing it into our post data object. And you can see here, this is our request object, and the API access token takes up a large amount of space. And you can also see the other values that we've hard-coded, like device ID, API endpoint, application ID. All of those are hard-coded, those three values. The API access token is one value right now that we are going to want to be dynamic, because that will change. And so after we now retrieve this very important information about the user's device, and we retrieve an access token, well, what is this access token going to allow us to do? Well, if you are a fan of REST, like I am, you can send a request to a service, and if you have the right password, in this case the access token, that service will return information that is detailed and private and can only be accessed with this secure method. And those details, those values, are what we are going to use to send a customized response back to the user. So we'll do that next. How's Eric doing out here? I mean, I don't know how he does it. The music every week is just perfect. I know he does spend a lot of time rehearsing and practicing. Don't forget, YouTube chat is open if you want to just say hi. hop onto YouTube chat if you have a question, a comment, or a suggestion. We got about 15 more minutes of this episode. I'm going to try and get through part 2 here a little bit quicker. What we're going to do for part 2 is we're going to update some C# code and create an asynchronous function within our web application. This asynchronous function is going to allow us to make a REST call to the Amazon API and retrieve information about the user. So let's check it out. Here we are back in our C#. And the first thing I'm going to do is, in order to read this a little bit easier, I'm going to use a Visual Studio command that will minimize, or collapse, I should say, each code block within the file. So you can see what I pressed was Control, then the letter M, then the letter O. So Control M O, and that will collapse all of your code blocks here. So it makes it a little bit easier to navigate. And the first thing we can do here, you can see if I zoom in, we're updating the HTTP post, I have trouble saying that, signature of our index, of our home controller. This controls the index view. And so what I've done is I've added the keyword async to the beginning of this signature, because we now want this method to be asynchronous. And when we do that, we get a little bit of a message from Visual Studio that says we need to return a type of a variable of type task for an async method. So when I first started working on this type of code, I didn't really understand it that much. If you don't work with this every day, this could be somewhat confusing probably. So I kind of just went along with it at first, and you do definitely understand this more and more as you work with it. But for the most part, we just want to remember that we're creating an asynchronous method because we need to call a service from another server, and we don't know how long it's going to take to retrieve that information. So we create a method that can be run asynchronously, and then everything else that's running can continue while this asynchronous method is going to get more information. So I've expanded our post function here, and you can see I've added the task modifier here at the top. So now we, in our signature, are returning a task of type iActionResult. Now that is the default type that you return when you are returning a view in an MVC application. Again, don't worry too much about this kind of stuff. Also, it just kind of depends on the type of web application you're building. If you're using C# or Java, I know Gabe likes to use Java a lot. I shouldn't say likes, but I know Gabe uses Java a lot. Haven't seen Gabe on the chat. I wonder if he's out there watching tonight. But any type of software application that you're going to write, you will run into the methodology of asynchronous functions. So I hope this helps you understand a little bit better. Now, after I added the the async property and then the task prefix there to our return type, we get a little message from Visual Studio that says now there's kind of a warning. Hey, you have an async function here, but you're not using the method called await. And so when I was first learning how to do this, I didn't quite understand, but within every async function, you must have what's called an await method. And we'll look at that now. So down at the bottom of our index code here, I've just sort of added another line on line 59. You can see that I'm updating our view data object because I want to pass information to the UI layer. And the information that I want to pass is the value I get back from a function called getGreeting. We haven't created that function yet, but I'm using the await method here because this getGreeting function is what we will be using to make that REST API call. And of course, using Visual Studio, we can see that we have an error here and can just generate a method with a click of a button. Here is the new method that is created by default. And we don't quite get it exactly how we want to, so I'm going to make a couple updates to this new function. And those updates, I've made that function an async function. And the return type of this function is going to be a string. Now, we can't just return a string because this is an async function, so we must return a task of type string. And we're going to get another warning here from Visual Studio because we are not using the await operator in this function. But just to get us started, what I do is create a variable called the return. And then I set that value just to an empty string and return that empty string, kind of just get us started here. Here's that warning from Visual Studio that we need to have an await method in this function because it's an async function. And so, just to recap, synchronous functions, they run one after the other and are a little bit more predictable than an asynchronous function, which, while it allows you to continue with what you're doing, they are a little bit less predictable because you don't necessarily know exactly when you will get a response. You can set things like timeouts and all that stuff, so it's a little bit more than what we will be doing for this web application, but almost done with episode 4. We're going to get started with our last part here. Just a couple seconds. We'll take one more quick peek in at our friend Eric, see how he's doing. Okay, so here we are back in our C#, and we created a new function called getGreeting. This new function will return a string. It is an asynchronous function because we need to place a REST call to the Amazon Alexa API. Now, if you've written web applications like this before, you've probably made a REST call or two. So hopefully this isn't too new. But in a nutshell, what this is allowing us to do is send a request to another server and retrieve data about the user. So the way we make that request is by creating an object called an HTTP client object. And you can see that on line 69. Now, just to initialize some of the properties for that new object, I'm going ahead and setting the base address to a new object of type URI, and when you pass a string to that method, you're given a new URI in return. Finally, I'm creating a variable called the JSON, and this is the line of code where we can use the await operator. We use the Alexa client object, and with that Alexa client object, we call a method called getAsync, and you can tell that the method getAsync is an asynchronous method because of the way it's named. There is also a get method, which is not asynchronous, it's synchronous. For this case, however, we are required to use an asynchronous function. Now, since I did not place a URL into the base address URI property, when I run the web application and click on the button to send the post request, I'm now getting an error. And I'm looking at the developer console here in the browser, and all I'm getting is a basic 500 error. I'm not really getting any detail here about what's going on, so if I need to debug this issue, I would either have to set a breakpoint in my code. There is another way though. You can also just sort of write the error to the console, and sometimes that's good because if you write out the error to a log of some type, when this is running in production, you can refer back to that log in a way rather than, having to rely on breakpoints and things like that. So what we are going to do is head back to our code, and within our getGreeting function, we're just going to place a simple try catch block of code here, and within the catch section we have a parameter called exception, or called EX. That is a variable of type exception, and what that allows us to do is anytime there is an error with our code or a bug, then rather than just sending back a 500 error message back as a response, what we can do is sort of customize our response here, and all I'm doing is taking the message from the exception, and that's what I'm setting the return value to. And one last thing I need to do here is place our REST code within the try block. So now when we run our web application and we send a post request, the post request is going to try this HTTP client get async method, and it will fail because we have not placed a URL into the URI section of the base address. There's also a second half of the URL that we will use and place that into the get async method. I'll show you both of those in just a second. But first, you can see now when we go back to our get page and we submit a post request by clicking the button, you can see we do not get a 500 error, but we do not get what the error message is quite yet. Now, while we have created a variable and sent back what that error message is, we haven't updated the UI layer yet. So back in our UI layer, creating a variable called greeting, which is now referencing the string that we're creating with the getGreeting function. And if I come down to our post section of code here, remember we have our text response, and we can sort of just add that value to our text response. Now this, again, is not going to be the exact way that we send our response to Alexa, so this will probably be the last time you see the actual hard-coded version of this response. In the next episode next week, we're going to create a custom response object so that we're not hard-coding any of this. Now, with our greeting value placed into our text, you can see when we click the button, our response is different. And the text now says, "Hello world, launch request," and then it gives us our error message, invalid URI. So that helps a lot when we're trying to figure out what's going on. Of course, you could always just set a breakpoint. So here we are setting a breakpoint on the catch block of our code. And when we run and click the button, you get the same error message, just in a different way. So the REST API from Amazon Alexa, we will talk about that a lot more in the next episode. I suggest if you want to take a look at the Amazon Alexa documentation, here they are talking about how to get the time zone of the Alexa device. There are a few other URLs here that allow you to retrieve other information. So that is the REST URL. Next week, we're going to take that API endpoint. We're going to combine it with an API URL. We'll put the device ID into that URL. You can see that's one piece of information we need to include with our request to the Amazon Alexa API. We're also going to send that API access token. Remember that access token changes about every 15 minutes in this case. So we need to send that password along with our request to the Amazon REST API. We'll do all of that next week. Whoa, okay. Need to change that to Sunday the 28th. Almost made it to the end. 28th. So episode 5 next weekend. I hope you come back to see us. Thanks again for joining us. Thanks to everybody who gave us a shout out in the YouTube chat room. This is Code and Coda. We are streaming live from Boston, Mass. every Sunday evening. Doors open at 9:15 p.m. You can watch Eric. Here's the Coda. See everybody next week.